Hello everybody and welcome to your Chem 113 review on mixtures and compounds. My name is Jason and I work for the ASU Tutoring Centers. Now when deciding between different types of mixtures versus elements versus compounds, there's sort of three main questions you want to ask yourself. So imagine you're starting with matter, right? All of the things we're going to be talking about are matter. So the first question you want to ask is it uniform? And we'll get into exactly what uniform means. So now, depending on how you answer that question, it breaks up into two different sections. Either you answered it no, at which point we would consider it a heterogeneous mixture. I think that's how you spell heterogeneous, something like that. If you answered yes, we would consider it homogeneous. Not necessarily a homogeneous mixture, like that example there, but we would consider it homogeneous. Okay, so once you're at a heterogeneous mixture, it kind of stops there. But once you've determined if it is homogeneous or not, it kind of breaks up into two separate things. We have to ask ourselves our next question, which is it made of two or more compounds, or two or more atoms, rather? Two or more, let me phrase this better. Is it made of two or more different atoms? That's your next question. And again, you can either answer this yes or you can answer this no. If you answer this yes, then we would consider it a homogeneous mixture, which is also called a solution. And it stops there. But if you answer it no, we would go ahead and consider it a pure substance. Okay. And pure substances can be broken down one more time. So you have to ask yourself one more question. The last question you have to ask yourself is, can it be separated into simpler substances? So can it be broken down, essentially? That's your last question. And if you answer it yes, it can be broken down, then you would consider it a compound. If you answer it no, this is the yes route. If you answer it no, it would be considered an element. Okay. So let me sort of emphasize our ending areas. So this is an ending spot, this is an ending spot, and then these two are ending spots. So this is your line of questioning you have to ask yourself in determining if this thing is a heterogeneous mixture, a homogeneous mixture, an element, or compound. These are your questions, okay? So we're gonna go ahead and ask ourselves these as we go through these examples. So let's start at salt water. So salt water, you just get some water, you put some salt in it, and you mix it up. So the first thing you ask yourself, is it uniform? And what exactly does uniform mean? So uniform means, so the way that I always think about this is, imagine you have a big bucket full of salt water, and you take a little cup and you scoop some out. Does that cup look exactly like that original bucket of salt water you had? And the answer is probably yes. Like if you look at them, right, if you observe them, you'll see water, and maybe you'll see a couple little flecks of salt throughout the water, but it'll look very similar in the cup as it does in the bucket. So uniform just means the entirety of it is sort of like evenly dispersed. Okay, the amount of salt you have is evenly dispersed throughout the water. You don't have like patches of water that have more salt than other patches of water. You might have like, because it kind of changes variably, but as a whole, on average, each portion of your salt water looks exactly the same as every other portion. So it would, in fact, be considered uniform. Okay, so it is uniform. So we're down here where this is now definitely considered homogeneous. But now we need to ask ourselves our next question. Is it made of 2+ different atoms? In this case, it certainly is, right? I mean, just the water itself is made of 2+ different atoms. Sorry, I should really specify 2+ different atoms or molecules. Okay, just being made of 2 plus different atoms is not necessarily right. So is it made of 2 or more different atoms or molecules? And it definitely is, right? We have all of our water molecules and we have all of our salt. Okay, that's 2 different things. So because of that, we would go down the yes route, and that means that we have a homogeneous mixture. There you go. So that's the line of questioning that we're going to go through for all of these. So now let's look at regular water. So is it uniform? And the answer to that is yes, right? Imagine you look at individual pieces of water, they all look exactly the same. So it is uniform, so we're over here at homogeneous. And then is it made of 2 plus different atoms or molecules? This is why I added this extra stipulation of or molecules. Because water is made of 2 different atoms, right? But in reality, if you zoom in on water, all you'll see is a bunch of water molecules, a bunch of H2Os floating about. So that's really one unit that water is made of. Just one unit, one H2O that's sort of copied over and over and over and over again. So we really only have one type of molecule. So we would go down the no route here. Okay, that's why I added that or molecules. So if you have one type of molecule evenly dispersed throughout, or one type of atom evenly dispersed throughout, we would answer no to this question. Okay, so now we're at a pure substance. And then our last question is, can it be broken down further? So if we were to, for instance, if it's made of a bunch of different molecules, if we look at those molecules, can those molecules be broken down into different elements? And the answer for water is yes, right? Because water can be broken down as some hydrogen atoms and some oxygen atoms. So it can be broken down. That means that water is a compound. All right, let's look at a solid bar of pure gold. Is it uniform throughout? Well, if it's pure gold, every little piece of the pure gold looks like every other piece of the pure gold. So it is uniform. Let me sort of erase these arrows so we know exactly where we are. It is uniform, so we're down here now. We're considered homogeneous. Then we have to ask ourselves, is it made of 2 or more different atoms or molecules? Well, no, right? It's pure gold. So it's made of just a bunch of tiny gold atoms. That's it. Just a bunch of tiny gold atoms. So we'd answer no. So we're down here at pure substance. And then can it be broken down? So if we look at the individual pieces it's made of a bunch of gold atoms. Can those gold atoms be broken down further? I mean, you could say they can be broken down into protons and neutrons and all that fun stuff, but no, you can't break it down to a further elemental piece. Right? Gold is an element. So you can't break down a gold atom to other elements. It doesn't work like that. So we're going to answer no to this question, meaning a solid bar of pure gold is an element. Right? It's made of one singular element, gold atoms. Okay, our last question. Last question is sand. So we look at sand. Imagine you're on like a beach. Now, if you were to take a scoop of sand and you were to take another scoop of sand, would those 2 scoops look exactly the same? The answer is probably not. Right? Sand is not uniformly distributed throughout. Some have like larger flecks of rocks in them. Some have maybe seashells in them. Different swaths, different pieces of sand look different from other pieces of sand. Sand is not uniform throughout. So we'd answer no, which means that we have a heterogeneous mixture. So sand is a heterogeneous. I don't know if I spelled that right, but you get the idea. Sand is a heterogeneous mixture. Cool. So this like hierarchy here, this is how you break down how we name different types of mixtures, elements, and compounds. This is the rule. These are the 3 questions right here that you really want to ask yourself when deciding if something is a heterogeneous, homogeneous mixture, or an element or a compound. Okay. Wonderful. So thank you all for watching. As I mentioned at the beginning, I work for the ASU Tutoring Centers. If you want more information on the free resources we offer on all 4 campuses and online, please check out tutoring.asu.edu. If you want more videos like this that go over specific concepts in your course, or maybe you want to see what upcoming review sessions we have for the exams in your course, go ahead and check out this link below. Thank you all again for watching, and I hope you have a fantastic day.